So in the last video, we did the 3 and our project because I noticed that quite a couple of the frames in the last video were frozen, right? The audio was playing, but the frames were frozen. So in the last video, we did the Django setup plus the custom auth. Now, before we want to take a look at wardrobe models or models. So I've already completed this, so let's just head over to wardrobe, wardrobe, and then the model, the wardrobe models that we have here. So we're going to have, let me make it a bit bigger so I can explain this line by line. I hope the last video was explanatory enough. I'm not sure. I'd like to see your review on it. So I'm going to, like I said before, I'm going to explain this line by line. And the function of the wardrobe application is to manage like the clothing, the seasons, the wear history, like the number of times you've worn a particular fit. I'm just saying FIT, Gen Z, images and AI tagging, right? So let's look at the models.py because that's what we're supposed to do in depot. So we're going to focus entirely on the wardrobe models. Okay, so there are 3 models in this wardrobe application: the season, the wardrobe item, and the WearLog. So I'm going to first take a look at the season model. So the season choices, we have spring, summer, fall, and winter. They're stored in top rows inside an array. So this is the value that's going to be stored in the database, right? Okay. So basically what this means is that this lowercase values are going to be stored in the database, while the uppercase values is what we are going to see displayed, right? Yes. So now the name here is just like saying that the name must be one of these. It cannot be like spiller or water. No, it can only be either spring, summer, fall, or winter, and they can only exist once. So the max length is 10, just like for formality purpose, and it's unique. So remember, we spoke about this string before, so I won't go over this again. So that is the season model. And let's look at the wardrobe item model. So this is what represents the actual clothing item. So we have the ID, we have this choices to category choices, top, bottom, etc. Tagging status choices, pending, done, failed. So the ID, actually, I'm supposed to import this from the common whatever, I completely forgot, but it's fine. So the ID is using UUID field like before. So instead of having like 1, 2, 3, 4, that is how it's normally stored in the database. It's going to increment itself automatically. So it's going to be 1, 2, 3, 4. But instead of that, I decided that like I explained this in the last video, but I chose this method. So I just wanted it to each to be special, but I use UUID. So they are harder to guess. UUIDs basically are harder to guess and are useful when you're like doing M2M relationships between the different MC models. So next is the user relationship. Now this is a foreign key, it's different from a primary key, right? Just wanted to make that primary key is for stuff like ID. Foreign key is for like a one-to-many relationship. Basically, you are linking the wardrobe item to a user. So a user can have many wardrobe items, right? So that's why I said it's a one-to-many. So one-to-many, one-to-many relationship. So this is like a how do I put this? Okay, an important database design. So why did we choose this set? Why did we have this settings dot alt user model? Why didn't we just import user from the account model? Why did we just use it? This is because this is like the best practice when you're using custom user model. There's nothing really too special about it, but this is like best practice. Now on delete models of cascade, what this means is that if the user is deleted, delete everything that is related to delete all the wardrobe items related to the user. So the related name just allows you to retrieve the user's wardrobe items when you, this is not part of the code by the way, when you type something like user dot wardrobe underscore items dot all. So if you do something like this, it will run. This is not part of the code, I'm just typing out something that's good that you could use. Next thing here is the name, that's the name of the wardrobe item, right? Like classic black blazer. So the max length is 225. It has a child field. Next, we have category. So it's based on the category choices I showed above. So basically, this choices field, this choices, I don't know what to call this now. This choices, let me say, constraints or confines you can, what can be stored here. If you put something like flexible boxers or something here, like you type that out when you're sending it through the front end, it's not going to run because it's not part of the category traces that we have here. Okay. Then we have primary color, we have secondary color. So the secondary color is optional. You can see we have blank true, null true. Primary color is the main color, right? And we have fabric, which is also optional. You can just include it if you wish. Fabric like cotton, wool, silk, denim, denim. Yes, that kind of stuff. That's what I mean by fabric. Then we have formality level. So the formality level has a range of 1 to 5. You see here. So 1 being very casual, 5 being the most casual. So it creates like a 1 to 5 rating as you see here with these validators. Okay. Now the next is the seasons. So the seasons is has a many to many field. Sometimes people would choose to use JSON field, or I chose to use a many to many field because one season can contain many wardrobe items. You can have many fits that fit a season, right? And um, so basically, one clothing item can work for several seasons. You can wear a shirt and a jeans maybe for spring, fall, winter, and vice versa. You can have a season containing many wardrobe items. So you can have several summer outfits for summer. That's what it basically means. That's why we choose this many to many field. Next, brand is optional. Image URL. So this is what is going to store the URL to the item's image. So the image URL is going to be uploaded via Cloudinary. You should have seen me mention Cloudinary several times in this code. Okay. Next is the tagging status. So this is for the AI tagging status, AI specifically. So the AI tagging system can have 3 choices. If you scroll back up, you would see that. So we have pending, done, and field. The default is pending. So basically, what the reason for this logic, or if I try to explain it, if you upload a clothing, it's going to be tagged as pending. So then it's going to be sent to the AI, and whatever the AI returns, if it's successful, it's going to return done. If it's not successful, it's going to return field. Do you understand? Okay. Now the next field we have here is times one, and I'd like to bring something here. Times one has a bit of an issue because while writing the code for views.py, I completely forgot to increment this. So we're going to see me write some live code as to fix that little bug. So times one stores how many times the item has been worn. So the next is purchase information. So this is the price, like maybe the cost of the outfit. So it's stored using decimal places. Sorry, the decimal field, because it's preferable to floating points when you're dealing with money. Then purchase date. This is optional. Created at and updated at. So these two were actually meant to be used from the common Windows.py here, but I forgot. So we'll just leave it as that. So this function here makes the object readable in Django, admin, or logs. So it's going to just return I said the name of the outfit is classic black blazer. The category, say outerwear, and then the email is going to be named like fashionista@gmail.com, something like that. So this meta class is just going to tell Django that the ordering should be according to the latest wardrobe items that have been added. So this negative means the descending. Okay, so now the next model we have is the WearLog model. So it records each time an item has or was worn. So the wardrobe item, this is connected to the wardrobe item model here into foreign key. I explained this before. So one wardrobe item can have many WearLogs. So that is why we connected it. Um, what's the next thing here? So the outfit ID is actually the UUID from the DolphJS styling service. So when we get there, you should remember me mentioning this. So instead of creating a foreign key, a database foreign key to another service, we simply stored the UUID string to it still belongs to the other service. One date records when it was won, created at is still the same as what we've been doing so far. Okay, so that is the wardrobe model. Okay, so I'm actually done, but I wanted to go a bit deeper. Like I wanted to explain this outfit ID in much more detail, right? Because you would expect that outfit ID should be a foreign key. Ideally, you think it should be a table, right? Or in this case, it's going to be like an inter-service interaction. Basically, the backend communicating with the styling service using this outfit ID. Now, that's not the case. You see, this what I call it architecture is mainly used in microservices application. This is not a microservice application, but this format is normally seen in microservice applications, because in microservice applications you have multiple services, right, communicating with one another. But here Django lives in the backend, and DolphJS, or the backend is with with Django, and the styling service is with DolphJS. So there are two different um, entities, right? So for them to communicate, you because the flow of Charis is basically that um, when when the user gets to the front end makes an API request to the backend. From the backend, it makes a request to the styling service, that's the WJ styling service. So the styling service creates or generates an outfit. So once the outfit is created, it then creates or rather an outfit ID, and then that ID is going to be sent to the Django backend, and then from there it's going to be stored in the Django backend. If we had instead used um, a foreign key, if we created another model or table for the outfit ID, we're effectively saying that Django owns the outfit table, which is not meant to be. It doesn't need an outfit table. It just needs to know that this wardrobe item, this WearLog, this wardrobe item is related or associated with this outfit or outfit ID, blah blah blah. So it doesn't need the outfit model because the outfit is managed by the DolphJS styling service. I hope you understand. So there's no need for a table. So basically, outfit ID is a UUID field rather than a foreign key because the outfit entity is is managed by the separate DolphJS styling service. It doesn't even the backend, right? You can see that here. This backend. This is styling service. Yes. So and the Django wardrobe application doesn't need to own an outfit table, right? It just needs that identifier of the outfit created by the styling service. So the outfit ID is in between, like it's just like will I say messenger between the the backend and the styling service. So it allows the two services to communicate through an API without creating any DB or sorry, rather database level dependency between them. So that's the reason for using UUID. I hope my explanation was clear enough. Okay, so that brings us to the end of the third video. We've completed the models or creating the model of the phone. So we're going to move on to the API now.